Now we will take up one more problem. The problem number 18. A horizontal rigid beam ABC of 3 meters long, hinged at point A. So hinged at point A is supported at B, is supported at the point B 2 meters from A. So 2 meters from the point A, and by 2.5 meters long vertical steel rod. So here we have a vertical steel rod of 2.5 at BDE, whose upper end E is hinged to a ceiling. So this is the ceiling at this point E, which has been hinged. The part BD is 0.5 meters long and 2000 mm square in area, while part DE is 2 meters long and 1250 mm square in area. If the beam carries a vertical load of 40 kilonewton, the beam carries a load of 40 kilonewton at the end C. Find the maximum stress in the rod and total elongation of the rod, and E is equal to 2 into 10 to the power of 5 Newton per mm square. So this is the problem which is given. So we need to solve this problem. So to do that, so first we will going to take the maximum stress in the rod. So this is the horizontal steel bar. So we are considering ABC. So here ABC, which is of 2 meters and 1 meter length, having the load which is acting downwards, which is 40 kilonewton. When the load is acting downwards, since it is acting as the cantilever beam, so the beam try to bend in the downward direction. So because in order to keep the beam in the equilibrium condition, there will be a force at the point B which is acting in upward direction. So that is the reason why you have an upward force P, which we don't know, we need to find out. So the maximum stress in the rod, let the tension in the vertical rod BP. So that is the reason why we are considering here, because since it is acting at the 40 kilonewton is acting downwards, so since it acts as a cantilever beam, it tries to bend in the downward direction. So in order to keep the beam in the equilibrium condition, because the load is acting downwards, there should be a load which is acting in the upward direction at the point B. So from the equilibrium of the rigid beam, taking the moments about the hinge at A, so what happens? 40, so the sum of the clockwise moment will be equal to anti-clockwise moment. So that will be equal to 40 into 3 will be equal to P into 2. Therefore, P will be equal to 60 kilonewton. So stress in the section BD. So now we need to find out what is the stress in the section BD. The load is acting on this cross-sectional area is 60 kilonewton, and since the area of cross-section is 2000 mm square, so what is the stress? Stress will be sigma equals P by A1, which is 60 into 10 to the power of 3 by 2000. So sigma 1 will be equal to 30 Newton per mm square. So then we have stress in the section DE. Now what is the stress in the section DE? Now the load is acting is 60 kilonewton divided by 1250 mm square. So here sigma 2 will be equal to P by A2. So 60 into 10 to the power of 3 by 1250. So on simplification, sigma 2 will be equal to 48 Newton per mm square. Therefore, the maximum stress in the bar will be sigma maximum on comparing these two. Here sigma 1 is 30 Newton per mm square and sigma 2 is 48 Newton per mm square. Therefore, maximum stress in the bar will be sigma maximum will be equal to 48 Newton per mm square, where the section is having the least cross-sectional area. So if you are considering these two cross-sectional areas, 2000 is the one here and this is 1250. Therefore, D is the section where you have the least cross-sectional area. Therefore, at that cross-section, you will going to get the maximum stress. Therefore, next, the total elongation of the rod. Total elongation of the rod will be delta L will be equal to delta L1 plus delta L2. Therefore, that will be equal to P into L1 by A1 into E plus P into L2 by A2 into E. P by A1 is nothing but sigma 1 and L1 by E plus sigma 2 into L2 by E, by taking the common factor of 1 by E, which will be into sigma 1 into L1 plus sigma 2 into L2. Therefore, that will be equal to 1 into 2 into 10, 1 by 2 into 10 to the power of 5 multiplied by what is the sigma 1, which is 30 into 500 plus 48 into 2000. So the total length of the rod, total change in the total elongation of the rod will be equal to 0.555 mm. So this is how you will be able to find the solution for this problem. And now the next problem will be problem number 19. A steel tie rod of 50 mm in diameter and 5 meters long is subjected to a pull of 100 kilonewton. To what length of the bar should be bored centrally so that the total extension will be increased by 20% under the same pull? The bore being 25 mm diameter, take E is equal to 2 into 10 to the power of 5 Newton per mm square. So here he says the diameter of the steel rod is 50 mm in diameter and 5 meter long. He has given 5 meter long. He is subjected to a pull of 100 kilonewton, so it is the axial pull. To what length of the bar should be bored? So that is, the boring has to be done here, bored centrally, so that the total extension will be increased by 20%. So 20% of the total extension under the same load, the bore being 25 mm diameter. Take Young's modulus of the material is given. So the rod without bore we will going to consider first. So extension of the rod delta L will be equal to P into L by A into E. So what is P? P is 100 kilonewton. So 100 into 10 to the power of 3 into length is 5000. 5 into 1000 divided by area of cross section is pi by 4 into 50 square into Young's modulus is 2 into 10 to the power of 5. So it will be equal to 1.27324 mm. Therefore, delta L will be equal to 1.27324 mm. So rod with bore. What is the rod with bore? Total extension of the rod delta L will be equal to what length of the bore we need to consider. So to do that, you are going to have 20% increase. So therefore, that will be equal to delta L will be equal to 1.27324 into 120 by 100. So total length of the bore, the total extension will be 1.528 mm. So delta L will be also, delta L is extension of unbored section plus extension of the bored section. So that is 1.528 is equal to 100 into 10 to the power of 3 into L. So what is that L? That L will be here this 5000 minus L. So 5000 minus L divided by pi by 4 into 50 square into E is 2 into 10 to the power of 5 plus then we have 100 into 10 to the power of 3 into L divided by pi by 4 into this bored section. So this will going to become the hollow cross section, which will be equal to pi by 4 into 50 square minus 25 square. So that will be area of cross section into E is 2 into 10 to the power of 5. So on simplification, therefore the length of the bore L will be, length of bore will be equal to 3000 mm. So that will be equal to 3 meters. So this is how you will be able to find the solution. Therefore, the length of the bore what is required here is 3000 mm, so that you will going to get the maximum pull or maximum extension of 20% under the same pull. So this is how you will be able to find the solution. Thank you.